Today onwards, we are going to start with JEE Mains, Neet and CET preparation for 2020. So let us start with an important unit from chemistry known to be solutions. So most of the MCQs regarding Henry's law you will come across. So what is Henry's law? The solubility of gas in given liquid at particular temperature is directly proportional to. Can you tell me which factor? Pressure of gas over liquid. So for simplicity, consider Xp, that is mole fraction of solute, as a measure of solubility of gas. So what relation you are getting for Henry's law? P equal to Kh into Xp. What are the terms in front of you? So P equal to partial pressure, Kh is Henry's constant and Xp is mole fraction of solute. So in addition to this theoretical part, keep in mind two important hints. Which these important hints? With increase in temperature, what happened to Kh? With increase in temperature, the value of Kh also increase, and ultimately what relation you have to keep in mind? Higher the value of Henry's constant for the gas, lower will be its solubility. So higher the value of Kh, lower will be the solubility of gas, and reverse will be the case. Next point. So next very important point in front of you, known to be concentration modes. So these are the different concentration modes in front of you: molarity, molality, normality, formality, demol, mole fraction, percentage composition. In addition to this, ppm and ppb. So in addition to regular concentration mode, focus on these two: demol concentration and formality. So what about first concentration mode, known to be molarity? Keep in mind, molarity nothing but, what is this? WB, weight of solute into 1000 upon MB into, what you have to consider here? Volume of solution in ml or cubic centimeter. What about molarity? Number of moles of solute dissolved in 1 kg solvent. So molarity can be given as WB into 1000 upon MB into WA in grams. What about third regular concentration mode? Normality. So what we can write for normality? Again, weight of solute into 1000 upon equivalent weight of solute into volume of solution in ml or cubic centimeter. Now, in addition to these three, what is next one? Formality. So formality can be given as WB into 1000 upon gram formula mass into, again we are going to consider volume of solution in cubic centimeter. So what fourth concentration mode we discuss? Molarity, molality, normality, formality. What about fifth one called as demol concentration? So demol concentration nothing but, first one, molar concentration at 0 degree Celsius. This is called as which concentration mode? Demol concentration mode. So what about next one? Mole fraction. So next important concentration mode in the form of mole fraction. So what symbolic notation used for mole fraction? X. So mole fraction can be given for solvent. XA nothing but number of moles of solvent upon total number of moles in the solution. Similarly for another component, XB, number of moles of that component upon total number of moles in the solution. What in addition to this one? XA plus XB equal to 1. Sum of mole fraction of solvent and solute equal to unity. So this is another important concentration mode. So after mole fraction, what we are going to consider for MCQ? Percentage composition. There are three methods known to be. First one, mass percentage. What is this? W by W method. What about second one? Volume percentage. This is V by V method. And third one, in combination, mass volume percentage, known to be W by V method. What about W by W method? Check this ratio: weight of solute upon total weight of solution into 100. What about a volume percentage? Change this ratio: volume of solute upon total volume of solution, again into 100. What about combined form? This is weight of solute upon volume of solution into 100. So these are the three sub methods in case of percentage composition. Now last two methods known to be ppm and ppb. What about ppm and ppb? These are the special concentration modes used only for very dilute solution. So what we can write for this one? First concentration mode for very dilute, parts per million. So how to calculate part per million concentration? 1 ppm, nothing but same ratio as we discussed in W by W, weight of solute upon weight of solution into 10 raised to 6. And for another concentration mode ppb, what you have to consider here? Weight of solute upon weight of solution into 10 raised to 9. So remember, pp and ppb can be used for what kind of solution? Very dilute solution. So this is regarding different concentration modes for numerical based MCQs. Next point. Whenever we are dealing with different solutions regarding molarity, normality, volume, etc. So these are the three possible conditions for already repeated MCQs. What is first one? For dilution of solution. So whenever there is a dilution of solution, what relation we are going to use here? When molarity is provided, use this relation. M1 V1 equal to M2 V2. If normality is given, similarly N1 V1 equal to N2 V2. So out of 4, 3 values will be provided and fourth one you have to find out. Then second case, for mixing of solution. Whatever may be the resulting solution system you are getting. So in that case use these two relations. M1 V1 plus M2 V2 equal to M3 V3. Similarly for normality. And what about third one? How much water to be added to obtain desired solution? So that is quantity of water to be added, that can be find out. Volume of water equal to what is this? Initial normality. N1 minus N2 upon N2 into V1. So remember, you have to consider initial volume of solution. So by putting these values, you can easily obtain how much water to be added from outside in order to get desired solution. So next factor, how to indicate acidic and basic solution. So keep in mind first one, when NaVa product is greater than NbVb, A indicate acid, B indicate base, then ultimately solution will be acidic. And for acidic solution, what you are getting here? H plus concentration. How to calculate H plus concentration? NaVa minus NbVb upon Va plus Vb. And that H plus concentration is utilized to calculate which value? pH of the solution. In case of basic solution, tell me, NaVa product is less than NbVb, so to be greater as compared to that for acid. So definitely solution will be basic. And what you are getting here? OH minus concentration from this. And this OH concentration is useful to calculate which value? pOH of the solution. Now, in addition to this one, what is the use of ionic concentration? Check this one. In previous point we discussed H plus concentration. So when H plus concentration is obtained, next step will be alpha into C. Degree of dissociation into C. So how to calculate degree of dissociation? H plus concentration by C. And what is the use of this alpha? So for acidic solution we can calculate acid dissociation constant Ka by using alpha square C. Similarly, what happen in case of hydroxyl concentration? OH minus nothing but alpha into C. Once again you are getting degree of dissociation how? OH minus concentration by C. Use this one for Kp